Okay. So, welcome everybody to this very interesting topic, zinc and lead update. Before we start with the webinar, let me introduce you the history and the present status of 13th Asian Metallurgy. Asian Metallurgy started as a ground show in 1996. It was a bi-yearly show and it used to be held at first Nehru Center and then Bombay Exhibition Center, Goregaon. But after COVID, we shifted it to the digital platform. And now, along with our other conferences, the 30th Asian Metallurgy Show is being organized every year now after 2021 on digital platform. What Asian Metallurgy consists of? So Asian Metallurgy consists of a digital exhibition, which is called as Steel and Metal Expo, along with few webinars, which we conduct alongside the exposition, dealing and addressing and debating various issues, various topics related to steel and metals industry. So this is the fourth one in the series, and we are now supposed to discuss about zinc and lead, which are very much part of the metallurgical industry. Though metallurgical industry is conventionally known for steel industry, many people say steel industry is the biggest industry under the umbrella of metallurgy. Yes, it is true that steel is the biggest industry, followed by aluminum. But I am seeing that the applications of the metals like zinc and lead are increasing. As you know, zinc and lead have very special properties as metals, and they can alloy with different metals and have definitely other applications. So what I feel is that zinc and lead are equally interesting, rather more interesting, because the metals like steel and aluminum have, I would say, matured to large extent. But the zinc and lead are still too mature, still many applications are about to be open to the industry. And so this is a very interesting topic, zinc and lead update. And we have got very eminent personalities, eminent experts in the field to discuss about the zinc. I would like to welcome Mr. L. Pugazhenthy. Of course, L. Pugazhenthy needs no introduction at all from the industry, whether it is steel industry, whether it is non-ferrous, whether zinc, lead, everywhere. He has been around for more than 4 decades, I believe, sir. And
we call him Bhishma Pitama.
Bhishma Pitao, absolutely well said, sir.
So I don't think so. There are many there.
No.
Steels to Sponge Iron Manufacturers Association, to the presidentship of Indian Institute of Metals, and now for many years he has been the mainstay of Indian Lead and Zinc Development Association, ILZDA, which is a very prominent and one of the very few well organized and well functioning or associations in the country, I would say. So welcome, Mr. Pugazhenthy, for sparing your time. Again, you were there for the inauguration function also, and now you are here for your close to your heart subject, which is lead and zinc. So thank you very much for sparing your time. Then we have Dr. Shantanu Chakrabarti. Shantanu Chakrabarti retired from Tata Steel as a head of research applications in November 2011. A mechanical engineer by profession and a PhD from Cranfield University, England. He has taught in universities and worked in Tata Steel in different capacities. As he worked in Tata Steel, mostly his expertise lies in the field of continuous galvanizing and fuels and combustion. He continues to conduct training programs and addresses national and international conferences on related topics. Ours is also international conference, sir. You can add this to your biodata. Post-retirement, he has been a distinguished visiting professor at IIT Kharagpur till 2016 and now a member of Expert Academic Review Committee for IIT Kanpur. He has been a member of National Committee for Government of India for Vision 2035 document. He has also edited the Anthology Evolution and Technology in Tata Steel 50-year narrative. That must be a very interesting document, sir. So, yes. Thank you very much for sparing your time, Dr. Shantanu.
Thank you.
Balo, and for being with us. And we have another expert, Mr. Sandeep Ramesh. Mr. Sandeep Ramesh, I will just, Mr. Sandeep Ramesh, thank you very much for sparing your time. Mr. Sandeep Ramesh is a commerce graduate and holds an MBA degree from Indian Institute of Business, Hyderabad. He joined Nile Limited in June 2009 as general manager of the lead division and has been in general or senior management roles at Nile Limited since then. During his period, Nile Limited annual reserves have gone from rupees 100 crores to rupees 800 crores. He is overall in charge of key functions including purchase, sales, and commodity risk management. He is currently the managing director of the company. Nile Limited is now diversifying into new areas, including lithium-ion batteries and e-waste recycling. Mr. Sandeep Ramesh serves as the governing council of the Vignana Jyoti group of institutions based out of Hyderabad. He is also chairman of Metals Recycling Committee of REIAI, Recycling and Environmental Industry Association of India. He has served as the vice chairman and subsequently as chairman of Tirupati zone of the CII, Confederation of Indian Industry, for the year 2019 to 2021. Thank you very much, Mr. Ramesh, for joining. We hope to have a very insightful and very interesting discussion along with all of these. But first, I will ask sir opening comments for everybody. We'll start with Mr. Pug. Sir, Mr. Pug, how is lead and zinc industry is poising? Because most of the people who are in metallurgical sector, they will talk about steel, they will talk about aluminum, they will talk about foundry, but not many people will know and they talk about lead especially and also zinc. So how is these industries doing? Zinc, of course, as we know very little about zinc. Apart from that, 70% of zinc goes in galvanizing. Apart from that, I am sure zinc has many evolving applications for the industry. So please update us, sir. Zinc and lead story.
Thank you, my good friend Chandekar sir. I know you for long, maybe 30 years or maybe more, and our relationship goes beyond metals here or steel here. In fact, you have been proudly holding the flag of metals and metallurgy for a very long time. You organize Aluminum Extrusion Summit in Dubai, in Bombay, etc., plus other steel events. Some of them I attended physically. Nehru Science Center, etc. I come to your events also. Yes. I know. So you are doing it, and we are all a part of your activity. Don't just tell me or Shantanu or Ramesh or Sandeep that we are sparing our valuable time. No way, it's a part of our job. And you are promoting zinc and lead by organizing this program. And Shantanu is an excellent speaker, excellent storyteller. I always have him in my conferences as speaker. Wherever I have, India, Nepal, Dubai, wherever I have, he is a speaker there. Similarly, Sandeep, I call him a young veteran in lead industry. He's a young veteran, I would say, lead industry. Okay. He is also a regular speaker. He makes excellent presentations. Recently, he was there in my Delhi conference on 2nd and 3rd December. And he networks with the industry so well. Now he's venturing into lithium also. Very happy to hear that, Sandeep, from you. Now, you were mentioning about my relationship with zinc and lead industry, sponge and manufacturer association also. But I think probably you would remember, I don't know whether Shantanu knows, I used to work for REIAI also in Delhi. REIAI Brothers, SR Group, SR Steel, SR Gujarat Limited, when they imported the hot bricketed iron.
In my introduction.
Did you mention SR?
Yeah, I mentioned SR. Journey started from SR Steel.
Okay,
I missed that.
Okay, I also missed that. And before that, I also worked for Mittal, Ellen Mittal, when he was in Indonesia as a small player, Surabaya, Ispat Indo. Then during my time in Delhi, we met the Trinidad Tobago ambassador. The first takeover of steel plant by Ellen Mittal took place when I was in Delhi. We both went and met the ambassador, did a lot of presentations, etc. Then the rest of the story goes about Ellen Metal all around the world taking over. And so I'm in a way, steel and zinc, lead, non-ferrous, as you rightly said, these are all a part of our game, my game. Now coming to zinc and lead, you mentioned about steel is widely used, aluminum is there largely used. Let me tell you, both zinc and lead are prehistoric metals. Prehistoric metals. Lead, for instance, the plumbing pipes were used by Greeks, Egyptians for conveying water, storing water, etc. So that is why the name plumbum for lead. That is how the PB symbol also comes. Zinc also is again a prehistoric metal.
Yeah.
If you go to Udaipur, there's an ancient heritage site in Udaipur where how zinc was distilled, thermal distillation, how they manufactured those centuries, how zinc was made, that was known in Udaipur. Today Hindustan zinc is there, but the ancient distillation columns are still there. And they even made brass in Udaipur. Not many would know that. They only know about the iron pillar in Delhi or some other Eiffel Tower and similar towers and all that. So both are very prehistoric metals, but both play such a role. You know, everybody talks about GI pipes, GI wire, GP sheets, galvanized corrugated sheet. Everywhere, zinc is there protecting the steel. The guy who is protecting the steel is not talked to, mentioned at all. Low profile pole. Everywhere, your galvanized buckets, galvanized tanks, galvanized guardrails and highways, galvanized telecom tower structures, transmission line tower structures, and also power solar energy supporting structure. Everywhere zinc is used, but that fellow is less known. Is protecting the steel, prolonging the life, maintaining the structural integrity, strength, etc. So zinc, as you rightly said, worldwide, 60% in rest of the world. In India, it's about 75% zinc goes for galvanizing. Other applications are zinc die casting, auto components, fuel pumps, carburetors, and many components which go in the cars. Some of them are converted into aluminum, and some of them will be converted in future into magnesium die casting also. But zinc die castings are known for its weight and strength. It's not a lightweight material like aluminum or magnesium. But zinc die cast materials are very, very prominently used in auto sector, even builders hardware, bathroom fittings, your knobs and many other builders hardware. They are all made out of zinc die cast, and then they are given a coating later. They are given a coating later. 1 second, let me just see. Yeah, I hope. Yeah. So zinc die casting is another. Then you also have dry cell batteries for your wall clock, your remote, TV remotes, or whatever remote, AC remote, whatever you have. Everywhere you have the zinc dry cell battery that is used in million numbers. Million numbers. Every chai wala, every general store, you will see them selling Red Eveready, Nippo, Novino, and various other batteries and all that. And zinc chemicals are also there, zinc chloride, zinc sulfate, and zinc oxide, etc., about which I'm not going to discuss in detail. Lead, of course, is a big boy. I think Sandeep will talk more about lead. Largely batteries, but then they are used in many applications. People don't know. The nuclear reactor walls, the bricks, the reactor wall bricks, they are all made of lead bricks. So that radiation does not go out and harm the society. Not many will know. Lead protects the society in nuclear reactors and surroundings, etc. So lead is again a very important material. It is a hazardous material, but there are programs for safe lead. How do you use lead safely? And everything is dangerous. Electricity is dangerous. Fire is dangerous. Mercury is dangerous, but the doctor puts mercury in glass thermometer into your mouth the moment you go. But you don't say anything, but mercury is protected properly in the thermometer. So there are many gadgets, many materials which are very, very risky. But lead also has got similar characteristic, but there are safe lead and green lead programs for lead also. That's all I would like to say now. Maybe others also would like to add, I think.
Yeah. Thank you very much, Mr. Pugazhenthy. Just one thing I would like to add that you were mentioning about ancient metallurgical contribution of India for zinc. So I think zinc extraction by distillation was known only to Indians till 16th century. I think that
Correct.
distillation process traveled from India to Europe, and then only the zinc extraction and distillation facilities were set up in Europe. So that is one thing we should boast about zinc. And I would like to now go to
One second before you go to the next speaker.
yeah.
Now worldwide, it is electrolytic process for zinc recovery.
Yeah.
Pyrometallurgy is not there very much in many countries. Maybe one or two may have. It
Uh,
is largely electrolytic
I
hydrometallurgical
know, I
process.
know, I know. But then
Yeah.
the extraction by distillation was first in India, and then
That's right. That's right. That is
from
true.
there it traveled to Europe.
Correct. That's true. Yeah. Now you can raise the question to the next speaker. Yeah.
Yes. That is our contribution. In fact, I know India has contribution in most of the metallurgical processes
Yeah.
in ancient times. Anyway,
Very
so
true.
now let's
Very
move
true.
on to
Yeah.
the next speaker, Dr. Shantanu. Dr. Shantanu, your opening comments. Then
Yeah.
after your opening comments, I will go to Mr. Sandeep also, and then we have few questions for the panel and you and Mr. Sandeep. Please, Dr. Shantanu.
Taking a cue from what Book said about zinc being known to people long ago in India, and the distillation was first done in India in the 16th century, if not earlier. In the old scriptures, there is a mention of a word called pushpanjan. Pushpa means flower, anjan means kajal. Kajal, जिस आंखों के लिए ladies लोग use करते हैं. So this pushpanjan is nothing but basically later it has been found out that it is nothing but zinc oxide, which in some form or the other was used by the Indian ladies back way before, much before 16th centuries. That means the process was not developed in 16th century. India holds the
No, I mentioned that the process traveled from India to Europe in 16th century.
in 16th century. India knew it from maybe 10th century, maybe.
Yeah.
Okay, I shift over to my experience when I went to England in 1979 to follow my master's and PhD in energy conservation and environment. We had important papers of global energy scenario and environmental scenario, and also heat transfer, several papers, thermodynamics, etc. One of the papers which dealt with the overall scenario of energy scenario in the world talked about that the total global resources of metals, of fuels, not metals, mainly fuels, was going to end. And the fossil fuels, it was in 1979, we read a book, we have the book, I had the book for a long time. By 2019, 2020, all the fossil fuels will go null, nil. There will be no reserve. So we have to conserve. So that was the scenario projected in 1979-80, and we had made project papers, etc., made presentations, etc., etc. But later, due to the development of technology, not only the exploration improved, but also the utilization has also improved. May not be to our satisfaction for the best conservation of energy resources, but still. So there are contradicting factors and changing scenarios. For example, the price at which zinc, lead, iron, steel, copper, aluminium, 100, 200 years ago, apparently on the figure price or cost figures in absolute terms appears to be much higher today. Even when Tata Steel began galvanizing in 2000 AD, zinc was 66,000 rupees a ton, 66 rupees a kg. I believe it is somewhere close to 300,000 today, 3 lakh kind of thing. But if you calculate or take into consideration the PPP, purchasing power parity, and the kind of inflation, it can be shown. In fact, I read a paper and I heard from a very legendary technologist who said that it has been proved and it can be proved that the price, absolute price in if you compare the time scale, it has not increased because we are improving on resource utilization. We are improving on recovery of the metal. We are improving on the technology. But definitely, there is no doubt the resources are depleting. And the best example is the field in which Pugazhenthy rules, and I have been his disciple in that respect, that zinc coating on steel saves it from corrosion. And there is an astronomical figure of corrosion loss for India. Every year, few thousands of crores of rupees are lost due to corrosion. And was a corrosion map made in the 60s, which has been recently upgraded, possibly. What are the corrosion intensities at different parts of India? Definitely, it's much high in the coastal areas. So definitely, galvanizing is first cost is the last cost. You don't have to paint like the Eiffel Tower being painted every 7 years, hand painted to prevent it from corroding. There's no question of prospect of galvanizing the Eiffel Tower. But definitely these are facts which we should be aware of. Along with the depletion of resources, almost hand in hand on the two sides of the same coin, is the environmental hazards and environmental load that we are making the earth tolerate that. I'm not going to the details that whether we should increase that or should it be tolerated. But definitely the issues of global warming, issues of greenhouse gases, issues of ozone holes are very much there. Icebergs melting, we all know. That's why when you talk of high strength steel today, coming back to steel from time to time, definitely we can't escape. The high strength steel in itself gives you a lot of strength and flexibility, fine. But the moment if you can coat it, which is a tall order, coating high strength steel and coating mild steel are different two ball games altogether. If you can coat high strength steel successfully, that gives a long-term solution for durable, corrosion-free auto bodies. So automobile manufacturers are shifting to corrosion-free material, giving a long life. Now comes the question of this carbon dioxide emission. The higher the load or the weight of the vehicle, the more is the emission of carbon dioxide. So you have to make it lighter. By the time I started my career in galvanizing, maybe steel content in a typical Indian four-wheeler was more than 1,000 kg. Correct me if I'm wrong. Today it has come down, or it has been replaced largely by thinner gauge material, which is called de-gauging. The gauge is being brought down, de-gauging. Why? Because we don't want the car weight to increase. But the moment you de-gauge the steel, make it thinner, it becomes weaker. The strength, the crash resistance degrades. So you have two contradictory requirements to balance. It has to be thinner, it has to be stronger, it has to be more corrosion protection. Difficult criteria, difficult conditions and parameters. These are the areas where new research is taking place. The moment you talk of zinc coating, and we thought we are the king, we are galvanizers. But then again, there is slow inroads by other alloys. Along with zinc, you put silicon, you put magnesium, you put aluminium, and a lot of experimentation taking place. The latest being, we have all seen, not the latest, we have all seen most of the main towns have used to have 40 years ago corrugated sheets, small shops and small outlets. Now these asbestos, these GC sheets, which replaced corrugated sheets, which replaced asbestos sheets, I correct myself. The galvanized corrugated sheets, which replaced asbestos sheets, have almost totally been replaced by galvalume sheets or the color-coated sheets. Everywhere, the color-coated sheets on rooftop, domestic, everywhere. Even if I look to the window on my left, I can see at least a dozen roofs covered with color-coated sheets.
Blue color. Blue colored.
Blue. Basically blue, and different colors are now coming.
Yeah.
Different colors are coming, not only blue. I have seen green, I have seen brown,
Correct.
I have seen red. Customer's choice.
Yeah.
This is basically silicon, aluminium, and zinc. Zinc has already lost its throne because aluminium has replaced it. In combination with zinc, it gives you better protection. And now the latest finding is the moment you add magnesium into it, the corrosion resistance increases tremendously, 7 times that of ordinary galvanized, 7 times more durable than ordinary galvanized steel. The moment you put, so Tata Steel, ArcelorMittal, ArcelorMittal, SR Steel, everyone is going in for these zinc cam steel, zinc aluminum magnesium. I conclude by saying that the technology does not stop. Change is the only constant thing, I would rather say. Changing scenario is the only thing that is going to happen. And once Pug mentioned, lead, mercury, chromium, all come under the umbrella of ROHS, restriction of hazardous substances. But at the same time, they are useful. They are beneficial if you know how to. And that's why, remember, the Bible I follow in my area of combustion and fuels is a North American Combustion Handbook. On its dedication page, there are 2 lines. I end my initial remarks by quoting that. Fire, F-I-R-E, fire, what if rained, comma, what if foe? It depends on how you use it. The knife in a murderer's hand and the knife in a sergeant's hand. So it all depends how we make best usage of all these hazardous substances. And of course, zinc and lead are absolutely at the vanguard of the entire procession. Thank you.
Excellent.
Thank you, Dr. Shantanu. Very insightful and very informative opening remark. Thank you very much.
Without any preparation at all.
You people don't need any preparation, sir. Your preparation you have done for last 4 decades.
No, still, it needs to be presented in a decent package.
You don't really need any preparation on the day of the webinar.
I call him Professor Shantanu.
It does.
Oh.
I don't mind because my father was a professor, my son is a professor, my brother is a professor.
Professors.
Sir, I have one more thing I have noticed. I have seen many executives coming from Tata Steel in the webinar, and they are all extremely good speakers. I must give you credit. I think initially you undergo a lot of training courses in Tata Group.
Soft skills.
Maybe soft skills, they pay very special attention to these, and they treat ET as their prospective MD. So that's how they look at it. I being from Jamshedpur, I know a little bit more.
Oh, acha, very good.
I studied in NIT, sir.
Oh, NIT. It was RIT at that time.
In our times, it was RIT. Anyway, let me move on to our next expert, Mr. Sandeep Ramesh. Mr. Sandeep Ramesh, please, your opening comments, sir, about the lead industry and how it is, what is the status, what do you think are the future prospects on these lines? Over to Mr.
Thank you, Chandekar ji. So,
can you make your volume slightly higher, if it is possible? This is the highest.
Is this better, Chandekar ji?
Yeah.
Oh.
Better.
Yeah. Thank you so much. So, to sort of move forward from where Pugazhenthy ji had left off, lead usage is only growing. If we look back, there's been a lot of talk over the last 4 or 5 years, especially about the adoption of EVs, the electrification of fleets, and the slow and steady movement to lithium-ion batteries. But if you look at the usage of lead, it was probably around 12 million tons around 2018, 19 or so, and now I think just last year we crossed 13 million tons usage. So that's consistently growing. Now it might not be in the low teens over the next decade; it might be in the low single digits, but it is still going to grow steadily. And we find that this usage is not just growing. Obviously, batteries remain the primary use case for lead, but even other than batteries, we see the usage, growing in other fields as well. For example, in nuclear-powered reactors, they obviously need a lot of lead to protect, for the radiation. So that's one area where we see a lot of it growing. It has come down in some applications such as solder because people are switching to lead-free solder. but the usage of lead compounds also, including oxides, lead salts, is growing. And there continues to be application of lead in some rolled and extruded products and in cables. So there is usage growing. And one of the major drivers we feel will come from the usage in stationary batteries. That's where we feel that the next leg of growth for the battery industry, for lead acid batteries in particular, will come from. While this usage of lead continues, another trend that has been increasingly growing over the last 5-10 years is the usage of secondary or recycled lead as a proportion of the total lead being used. Earlier, of course, there was a huge shift towards primary lead, and secondary lead was, in fact, I think even as recently as 20-25 years ago, a lot of battery manufacturers were hesitant to use secondary lead in their batteries. In fact, I think even Exide and Amara Raja, the two main large battery manufacturers in India, shifted to secondary lead only around. Amara Raja, I think, was using only primary lead till almost 20 years ago, and then they gradually made the shift. In Japan, a lot of battery manufacturers only used primary lead for the longest time. Then they slowly started to make the shift. So across industries, we've seen the shift has happened. And now, even within the battery industry, except for very specific alloys by some battery manufacturers, secondary lead has been proven to be as good in terms of its life cycle usage, in terms of its properties, as primary lead. So I think that's a trend that we're seeing, the increasing usage of recycled lead. There are a few reasons for this focus on recycled lead taking over. One, of course, is the increasing focus on sustainability and resource conservation that's happening everywhere, all across the world. The second thing is the recycling industry has established and become more mature. Even in India, we see, if you look at things 15 years ago, there were probably very few formal recyclers. And probably even some of the so-called formal recyclers were using mandip bhattis and very crude furnaces to process the lead scrap. But we've slowly seen players adopt more efficient, more technologically upgraded machinery, more exhaustive pollution control equipment to become more environmentally friendly. The greater use of automation and material handling equipment, such as automated battery breaking machines to process large volumes of scrap, environmentally friendly equipment such as oxy-fuel burners, wherein you're using oxygen to make sure the smelting takes place in a more environment-friendly way. So all of these things have, sort of helped the recycling industry. While they've actually adopted a lot of these measures, what also happens is that they find the yields and the recoveries from the processed scrap going up. So it's a win-win situation. You invest more in better plant and machinery, you see better yields and better recovery, so your commercial viability goes up, and then you reinvest those proceeds to improve in some other areas. So those are some of the things that have helped. And another factor that has really helped, I think, the recycling industry take off has been the Government of India's incentive for recycling. And Pugazhenthy, of course, has been one of the front runners in this. The earlier rules were the DMSR rules, which in 2001, which spoke about how all producers, manufacturers, and importers of lead or lead devices that contain lead, such as batteries, were responsible for ensuring that the end-of-life batteries or end-of-life lead was diverted to authorized recyclers. Now, these rules were replaced with BWMR 2 years ago, Battery Waste Management Rules. These rules have now also started to incentivize formal recyclers. So, earlier it was sort of a stick approach towards the importers and the manufacturers of lead. Now there is also a carrot being used, incentivizing people to shift to recycling and to reusing the end-of-life waste. And if you're doing that, they're getting benefits in the form of EPR, Extended Producer Responsibility Credit. So these are some of the factors that have helped, enhance and encourage recyclers. And we find that now India has one of the most robust and domestic lead recycling networks in the world, as good as probably what's there in Korea, Japan, the United States, Germany, Belgium, countries that have really progressed very well in terms of lead. And we find that that's very important because this robust recycling network also helps there to be enough raw material readily available for the lead acid battery manufacturer. Because if you look at what is happening with lithium today, we are talking about getting into lithium-ion battery manufacturing, but we don't have any natural resources. All of the lithium is pretty much in the ABC triangle, Argentina, Bolivia, and Chile. And of course, there are some mines in some other places such as Australia, Canada, and China. But the resources have been largely concentrated in a few countries. India doesn't have natural resources. But similarly, if you look at lead, we have only one primary lead producer in the something. But because of the large secondary lead recycling infrastructure that has been built up in the country, we are able to now import raw materials such as lead scrap, lead batteries, and process them to ensure that our battery manufacturing industry has enough raw materials readily available. So, that's, I think, a place where we have really made a lot of progress, and we've been helped by the government of India's incentives and the recent regulations that have come up. So that's my 2 cents about lead, and I think the way forward for lead, things are looking very good. There is a lot of R&D going on in terms of new applications for lead-acid batteries. People are coming up with carbon, the usage of carbon in the batteries. People are talking about different types of batteries, which will not only reduce the amount of lead that is going to be used in the battery, but also increase the life cycle and the durability of the lead-acid battery. So that in terms of, if you look at the LCE, the lifelong cost of ownership, it will probably end up being as good as any source out
Yeah. Thank you, Mr. Sandeep. It was very interesting to know about many facts of lead industry, which otherwise were not very commonly known. Mr. Pugazhenthy, how do you see the future of this? Because of late, there is some added emphasis apart from the metals like, apart from steel, aluminum, and copper, we have started giving some importance to other metals, the alloys prepared using other metals for some specific application in semiconductor or maybe in batteries and other application. How do you see the future? It should be governed by the innovations and the new applications, sir.
1 second before I go to specific question, 2 observations from both Shantanu and
Yeah.
Ramesh, Sandeep, Ramesh there. Actually, I'm adding some points for the benefit of the 3 of you.
Please.
Rightly, Shantanu said all the natural resources will face depletion gradually, etc. I was mentioning. I was just seeing a graph very recently from International Energy Agency, IEA. The thermal power is going down in the curve. Solar going up like this, followed by wind also like this. Hydropower flat, nuclear power flat. So thermal power, fossil fuel, the whole world wants to phase it out. But unfortunately, in COP29 or international discussion, they end up in a deadlock. They are not decided to phase it out. But India has already started. Our renewable energy is going up, 176 gigawatt now in the country, installed capacity. So what Shantanu says, we are now seeing it. The other point as an academic point, I wanted to mention to all the 3 of you, in Bureau of Indian Standard, there is one specification for primary lead. There is another one for secondary lead. Now, what the customer thinks normally, primary lead means high purity. Secondary lead means there will be impurities. The idea of saying that primary lead, primary route is from natural resources. Secondary is the other route, secondary route from recycling of all the. This is not there. So I used to tell them we should find a way. The customer will immediately secondary means sasta milega, impurity hoga, all kinds of notions will be there and all that. I'm sure Sandeep will note my point. Now coming to your new uses, etc., it's already there. Not a zinc oxide, for instance, is used in electronics and semiconductor industry, zinc oxide as a chemical. Now, where does zinc oxide come from? How do you manufacture them? Very simple. In galvanizing, whatever zinc dross is formed and settles at the bottom, a waste product, inevitable waste product, a galvanizing tank, dross is there. On top, there's a surface oxide product, zinc ash. what we call zinc ash and zinc dross. Now, every galvanizer will always generate, apart from coating the steel, at least 25-30% of both ash and dross put together. That is an inevitable waste, but it is a potential material for recycling, and India is encashing the benefit. All the zinc dross from the galvanizers, wire galvanizers, tube galvanizers, structural galvanizers, any galvanizer for that matter, zinc dross is taken and that is converted into zinc oxide. There are a number of manufacturers in the country, JG Chemicals, Navbharat Metallic Oxide, etc. They are making zinc oxide from a waste product from a galvanizing plant, and that is going for electronics and semiconductor industry, etc. And the zinc oxide also goes for paint industry, pigments, and also ceramic, etc. It goes to many other sectors. So there is already, you said innovation, but it's already happening. And so new users, we are doing, for instance, in the case of die casting, we are trying to go for alloys, Zamak alloys, zinc containing aluminium, magnesium, and copper. And that's an alloy. And that is the one which is used for die casting, not pure zinc. It's an alloy. Different 4% aluminum will be there and all that. And that is used very largely for all builders, construction products, automotive products, everywhere being used. So this is what I would say about zinc as far as new markets already happening, but not known to the general public.
Yeah.
Yeah.
Dr. Shantanu, I would like to ask you that how do you see the future of galvanized sheet, as Mr. Pugazhenthy was also explaining, especially galvalume?
I would rather make a corrigendum in the sense that what Pugazhenthy talked about ash and dross and 25%, I think he referred to general galvanizing and batch galvanizing.
Correct.
What we have in continuous galvanizing, which is predominantly just the sheets from 1000 millimeter width to 2000 millimeter width, or it varies plus minus 150 this way, that way. So those continuous galvanizing plants, which run at speed of 100 to 200 meter per minute through pure zinc, super high grade zinc, containing very little trace amounts of tin, lead, antimony, etc., or free of them. They are definitely spreading their wings in the sense that refrigerator, washing machines, pathways, cable trays, everywhere and I have seen in countries, in advanced countries in Europe, the paint business has suffered very massively because everything in public domain is made with galvanized steel. If not stainless steel, then definitely galvanized steel. So definitely, as I said, zinc will rule the supreme for quite some time. And as I said in my opening remarks, that the technology is changing from asbestos to galvanized corrugated, from galvanized corrugated to galvalume, from galvalume to zinc aluminum, magnesium, etc. Developments in galvalume sheets is definitely going to take place and continue. Unless and until there is some other element making its inroad, which is economically justifiable, galvalume will rule the roost in the sense that for all construction purpose, for all roofing purpose, galvalume will be the last word that way. For specific applications like solar engineering or electronic engineering, we had another kind of galvanizing process apart from continuous galvanizing, that is electrogalvanizing. As far as my knowledge goes, who may certify or contradict, there is no single electrogalvanizing plant in India. There is nothing.
No.
And in the last 15, 20 years, all over the world, there is hardly two or three or four plants that have come up, because all the manufacturers, international manufacturers, are going out of it because of cost purpose mainly. But the advantage of electrogalvanizing was that you could produce very thin coatings, 10, 15, 20 milligram per square meter, Whereas normally what we do for standard sheet galvanizing is 60 to 150 or 200 grams per square meter. To summarize, galvanized sheet has a tremendous future. Sheet galvanizing in continuous galvanizing and newer applications with little bit additions of different alloys will rule the entire market. Galvalume may go through another kind of development to increase the corrosion life that way. And what I remember before I retired in 2011 in Tata Steel, what we normally do in galvanizing, hot dip galvanizing, after the sheet is galvanized, ordinary for roof sheets, the corrugated sheets, we passivate it so that it does not actively react with the atmospheric oxygen. We dip it into a chromate tank, potassium dichromate, hexavalent chromium, hazardous substance, but the quantity contained per square meter is below the permissible limit. But that is a notorious, poisonous, hazardous, cancerous chemical, no doubt. But it does the job like nobody else. Replacement of passivating chemical, replacing hexavalent chromium with trivalent chromium or zero chromium has also been being researched, and there are manufacturers who are using trivalent chromium for passivation so that zinc coated sheets are largely accepted, because hexavalent chromium coated sheets, or rather passivated sheets, are not accepted in USA or in Europe. So we also researched, I don't know the latest status at Tata Steel, but they did some kind of a resinous coating which does not contain a trace of chromium at all. But that does give you a protection, that gives you a shine, and that gives you a protection. Whether that is economic enough, whether that can withstand the corrosive atmosphere in difficult atmospheres, is yet to be properly proved. But whenever you look at the Galvatech proceedings, the kind of international conference on galvanizing, which happens every 3 years, Japan, Europe, USA, all these places, China, the kind of trend is development of newer alloys, development of economic processes of coating steel with zinc and its alloys and other alloys. To summarize in one sentence, tremendous future with infinite probability of newer developments. That's how I would like to summarize.
Thank you. Thank you. Thank you, Dr. Shantanu. It was really heartening to know that the future of zinc and galvanized products is bright, very bright, in fact. And now I move on to Mr. Sandeep. Mr. Sandeep, what do you think is the future of lead? Of course, it must be positive, but please elaborate. And maybe one of the threats which is posing a threat to lead development of recycled lead. This thing is that unorganized sector. So how do you see the threat of unorganized sector in the lead business?
So Chandekar, firstly, I think, there have been some, if you look at, lead versus the other chemistries right now, we see, lithium obviously gaining some traction. But there are, if you look at, in terms of the total cost benefit analysis, if you do that, it is really difficult to look beyond lead for certain applications. Lead, there are certain, if you look at, for example, two-wheelers. In two-wheelers and three-wheelers, we see that lithium is making some progress, is making some headway. But lead, for the larger applications, for the larger vehicles, for example, lead continues to be the dominant driving force. Now, there are other things such as, there are a lot of other uses. If you look at, for example, the government of India is putting a lot of focus on renewable energy. All renewable energy projects, solar projects above a certain capacity will have to have connectivity to the grid, and will also have to have backup power. So for backup power, the most cost-effective solution remains lead-acid battery. So even though the share of lead in specific, even specific subcategories of the automobile space, such as two-wheelers and three-wheelers, a part of that might be going towards lithium. That will be more than offset by the extra growth that will be coming in from other sectors, such as the backup power demand for backup power batteries for solar, for example, as mandated by the government. So we actually don't see that impacting the demand for lead going forward. With regards to the informal sector, that has been a concern, but we believe that has been largely addressed due to some of the provisions that have been incorporated into the VWMR. For example, one of the things is that all battery manufacturers will have to, they are mandated, the impetus has been put to ensure that waste batteries are only disposed of to the authorized formal recyclers. And if that is not done, there will be a penalty imposed on them. I think they have a restriction between, depending on the type of battery, whether it is an automotive battery versus whether it's an industrial battery. Starting off with 50%, every year there will be an increase. Till year 4 or 5, 90% of the batteries that are sold in the market, 90% of those batteries have to be collected and channelized back to the authorized recyclers only. Otherwise, there will have to be a user fee. So that is actually going to incentivize more and more end-of-life waste to go towards the formal recycler. The second thing that will benefit is, there was a discussion, and in fact, Pugazhenthy was also an integral part of the discussion. What is happening now is we find that the batteries might be channelized to informal recyclers, and they make the crude lead or bullion, and then that bullion might be available in the market for formal recyclers. But the new rules mandate very clearly that the credit, the EPR credit or the extended producer responsibility credit, which can be used by the battery manufacturers to offset any shortage in their compliance requirements, will only be generated and given to companies that do end-to-end recycling. That means from the battery that comes to you, the end-of-life battery, you not only have to manufacture the crude lead, you have to go one step further and manufacture either the refined lead or the lead alloys that is directly used again by the battery manufacturing industry. So only if you have the end-to-end infrastructure in place will you be able to generate the credit. So this again incentivizes people with larger scale setup who have the end-to-end facilities in place. So these are some of the things that I think are helping. And I think the CPCB, the Central Pollution Control Board, has also started mandating tougher checks and tougher compliances to ensure everyone is on the same wavelength. However, one thing I think that can really help is, the GST. The GST right now is 18% on waste used as a battery. And this creates a lot of undesirable outcomes. A lot of, people trying to create fake bills and, because of the 18%, people don't want to pay that 18%. So if that can be brought down, that will prevent and hinder people from doing these unethical practices. And that will ensure more flow of waste to the formal and authorized. I think that is one very important thing. I think the Metal Recycling Association of India and then other lead bodies have also been pushing for the government to make this change. If that is done, I think that will definitely restrict the flow of waste to the informal sector. And finally, if I may add one last point, I think a certain amount of scale also brings across benefits, unit economics. And I think what we've been seeing is that recyclers are going larger and larger size furnaces, larger size kettles, and that is also helping them gain more benefits in terms of the processing cost. The processing cost per ton of block of lead or per ton of finished product is actually coming down because they're able to harness these larger economies of scale with larger machinery and better output.
Thank you. Thank you, Mr. Sandeep. Very insightful, very informative. And one of the very important points you made was that you wanted that the GST rate should be reduced from 18%. Yes, of course. Mr. Pugazhenthy, actually, I wanted to ask you this question only. What policy support does the lead or the zinc industry need from the government, from the administration? What policy support?
I would think straight away, for instance, in the government sector, for many activities, they believe in tendering. And the tendering, they always think of L1. And the L1 means many times they say, why do you want to go for galvanizing? Department mein there is no money, go for painting. Agle saal dekh lenge. This happens with municipal corporations and even state governments and many places. So there's no money. The deficit budget in many states in the center also. So this is not correct. And many engineers all have been telling in our conferences, we know very well that galvanizing lasts for lifetime. This is the view of galvanizers working in PWD, CPWD, MES, many
Yeah.
places. But this
Yeah.
L1 is not a meaningful thing. Wherever you have, they should go for life cycle costing. Go for galvanizing. Maybe the galvanizer you negotiate or have some rescheduled payments, etc.
Yeah.
So
Yeah.
this is something very, very wrong. This happened for electricity, for telecom, for lamp poles in cities and towns, etc. So
In
that is
construction
one.
also, steel was being quoted earlier.
Sorry?
In construction industry also, steel was, being painted or
Yeah,
coated,
yeah.
that PVC
Even,
coating and all that.
e- even today in cities of India, go
Yeah.
to
Yeah.
Delhi, go to Hyderabad, the foot-over bridges, they will all be green painted.
Yeah.
And
Yeah.
many parks and many places, public infrastructure, railing, painted. You paint, you have galvanized them, 50 years, you don't have to just think of them at all, unless it becomes rusted or it becomes very weak and all that. That's one important point that I want to mention. Now, one or two things I think we want to clarify.
Galvanizing should be made compulsory.
Yes,
Mandatory.
That's exactly I'm telling. All engineers come and tell in our seminar, CPW, we know very well. We are using in our house GI pipes, galvanized sheets for maybe garage or whatever. We know jolly well. But the department, the finance fellow says, go for L1. So they just keep quiet. So this is the point that I wanted to mention. One thing I wanted to clarify, for instance, Shantanu was telling galvanized steel sheets have been replaced by galvalume and then magnesium, etc. Actually, in real terms, galvanized sheets have been replaced by galvalume in much larger tonnages. If you go to any construction site for paneling,
Everything,
they
everything
used to,
galvanized.
it's all galvalume now.
All.
Earlier it was galvanized steel sheet. So you may think there is a reduction in zinc usage in galvanizing, sheet galvanizing, but actually more zinc has gone in galvalume. That contains 45% zinc, Shantanu, in the
Yes.
bath.
45, 53% aluminum and rest is silicon.
Yeah,
45 zinc.
so 45% zinc is there in the galvalume bath, and that is really going up. Everywhere you are seeing warehouses and factories, and everywhere you see this, even small sheds, etc., they are using galvalume. So, in fact, the real growth has taken place in zinc usage. You think you are lost somewhere, but you're using much more. That is one point I want to mention. And secondly, in the informal sector, you are asking our friend Sandeep. Actually, for a long time, for your information, the dealers, battery dealers in the country, they are the mischief mongers. They collect the old battery from you, they give it to a middleman or a merchant, and he gives it to the informal sector. And this is all by cash, no billing, no GST.
Yeah.
Cash, that's it. And these guys are all really flourishing, and that is how it's been going on. Your battery, next time you ask your dealer, मेरा पुराना बैटरी कहाँ जाएगा, वो तो 10 बैटरी होने के बाद एक आदमी आता है, they fix it up in a 3-wheeler, 4-wheeler. So this is the nexus between dealers, middlemen, and the informal sector. So my point, in fact, in the earlier battery management handling rules about which Sandeep was referring to, we mentioned very clearly all the battery dealers in the country, they should be registered with the local state pollution control boards. They should give half yearly returns. How many new batteries were sold? How many old batteries we collected, and where it has gone? Registered recycler or the secondary route, informal route. This kind of thing was there in the earlier battery management handling rules. But the current one, battery waste management rules, which Sandeep talked about, dealer is not at all there. And I have been telling MOEF and CPCB, we are not plugging the problem properly. finally you will say battery waste management rules has failed because you never attended this fellow dealer to be made accountable. Can you believe Shantanu and Ramesh and Chandekar at my last 2nd, 3rd December conference? I had an idea there must be 10,000, 15,000 battery dealers in the country. The battery companies, they were telling there are 1 lakh battery dealers in the country. Every nook and corner, every lane, Exide hoga, Amar Radha hoga, and there are many of them. They reconditioned the battery. They put their sticker. Locally, they sell old battery container, and they just put acid, put whatever they want to put, plates and all that, and they sell it much lower price than branded batteries. And customer, ये तो सस्ता बैटरी है, मेरा स्कूटर के लिए ठीक है, मेरा गाड़ी के लिए ठीक है, 1.5 years life, that's all. Whereas Exide you will get 4 years life, or Amaran you will get, Tata Green you will get 4. So this 1 lakh dealers, can you believe this? I have sleepless nights, and they are the ones who are adding to the growth of this informal sector. We have to plug them. Finance ministry is losing revenue, and the informal sector is recovering less lead, more lead in the air. See all the damage, environmental impact. So this is something which needs to be done. Dear Sandeep, do you agree with me?
Yes.
Absolutely. That is one glaring omission in the new rules. They have
Correct.
EPR was a very good thing that they did. They put more pressure on the battery manufacturers, but the glaring omission has been the lack of any monitoring or supervision by completely removing the dealers from the whole chain.
Yeah, that is one thing. Sir, another point
The
which
thief has been let off.
yeah,
So the thief has been let off. Thief has been let off. What did you say?
Yeah.
What were you telling? What were you telling?
Sir, one more point I wanted to mention here is about FTAs. We have done
Huh?
FTAs with FTA, free trade agreements.
I know. Yeah.
And we have done FTAs with certain countries, and I find that some, because FTA necessitates that there is no import duty. So I am seeing
Yeah.
a lot of the non-ferrous material, even zinc, is coming through this FTA route, and that is posing competition, unfair competition to our domestic industry. What we have to say about it?
Actually, we have an FTA with South Korea.
So let me clarify. My take on this: when government is making FTA, they are making it for many geopolitical reasons, which is perfectly justified. But they should also take industry
WTO,
into confidence. They should also take industry
WTO
into confidence while they are doing FTAs. That is my point. Please comment, sir. All the three.
See, actually, what you said is our WTO stipulation. WTO, unka
Yeah.
stipulation hai. Now, India also depends on South Korea for car, Hyundai, a lot of investments are taking place here. And there is one company, Korea Zinc in South Korea. We have an FTA with South Korea, but they are not able to sell much in the country. So Hindustan Zinc is a large player, almost 1 million ton of zinc they're producing.
About many non-ferrous metals.
Yeah, and then zinc is large supply from Hindustan Zinc, and Sandeep will tell you there's plenty of lead recyclers in the country. About 1 million, 1.1 million ton of recycled lead is floating in the country. So no way FTA South Korea can try to bring their material here.
So
Even if
that is a good thing. I just wanted to check
copper में हो सकता है, because there you have got other problem, copper concentrate, import and all that. But fortunate, Sandeep, do you agree with me? Korea Zinc, are they dumping lead here in the country?
They are not, Pugazhenthy, but I feel, yes, you're right in that, there's a lot more capacity for recycling here, and that's a good thing. But I think Chandekarji has a point when he says, the end user industries are benefiting from this, but not necessarily the whole sector. Because if you look at the recyclers, all the recyclers in lead, we now have a problem because the finished product, it's not just Korea Zinc. Korea Zinc is obviously, one large player in Korea for primary lead. But you have a lot of secondary lead manufacturers, recyclers in other countries like Thailand, Vietnam, and all of them. Now they're able to get the benefit of this duty-free agreement and ship the material at a lower cost. Whereas the recyclers in India don't have that benefit because the raw material is still being imported, paying customs duty of 5%, 5.5%. So it may put us at a disadvantage, and we're not really able to compete very well. Especially when you also consider that to begin with, we are at a disadvantage because the freight costs to India are significantly higher than a freight cost to a lot of those other countries. So we firstly pay customs duty on our raw materials. Secondly, we incur larger freight. So we also can't export our finished products as competitively as some of those other players. So I think there should be a reduction in the raw materials import duty.
Understood, yeah. ASEAN countries, we have FTA. ASEAN.
Not for the raw
South
materials.
Korea, we have FTAs with many countries in Southeast Asia. So for a person, the
No.
person is situated in Calcutta, maybe it is better to import via sea route than getting from Bombay, Ahmedabad or
Yeah.
Chennai.
Yeah, correct. Thailand or somewhere you will import, or maybe
Yeah.
Malaysia, maybe, yeah.
Yes, that's what.
Yeah.
So anyway, my point was that whenever government is doing these FTAs, I perfectly understand that there is a big geopolitical reason and logic behind it. But at the same time, they should also take industry into consideration. They should
But
also
they
take
don't.
industry into
But
confidence.
they don't consult with the industry much.
That's what.
It's
That's what.
purely
That is what my point is, sir.
Ministry of Commerce goes ahead. That's it.
Yeah. But industry, what impact does it will it have on industry that they must consider, no?
Yeah.
Anyway, that is what was
even
my point.
even the GST issue which Sandeep was mentioning, Finance Ministry will say this is GST Council matter, not my matter.
But
GST
GST
Council has
Council
to.
is very big group, no sir?
I
GST
agree.
Council itself is very big group.
I know it. They're a big setup here. Yeah.
Yeah. Anyway, so
Acha, one more thing. You are asking the future of lead with Sandeep. This lithium, all the stories happening. Okay.
yeah.
This lead battery supported inverter in India. That's a growing market. Again, UPS for computers, below your computer, you have an UPS. Again, that is a growing sector. Telecom towers, more mobile, more connectivity, and every telecom tower has a bank of lead batteries to give energy to the tower and all that. So these are the areas where lead is growing and growing in this country for a variety of reasons. Let lithium come, let somebody else come. We are not worried.
Anyway, sir, it is more than 70 minutes now. We are discussing lead, zinc and lead. So I would like to make everybody, that everybody should make a very short last comment. And let us close this discussion. We had very fruitful discussion, but now, starting with Dr. Shantanu. Very short. Last
The
comment.
point I'm going to mention as a concluding remark, I think Pugazhenthy will echo and there will be resonance between our thoughts, is that the Government of India, especially Bureau of Indian Standards, BIS, is very, very weak, if not almost non-existent, on the standards of galvanized product. There is BIS 277, which was maybe 50 years old, maybe 20 years ago, that was revised. But apart from that, the different kind of products that are being manufactured by Indian industries like Jindal and Tata's have not found favor with the standards formulation body. We need standards to prove that we exist, and our quality is exportable quality. We are exporting. But the question is, the Indian BIS is sleeping on it. I remember I retired 12 years ago. 20 years ago, we had a meeting with Manak Bhavan in Delhi, where we tried to impose on them, or rather convince them, that we need standards on galvannealing. Galvannealing is a slightly modified method of galvanizing with iron and zinc layer in the interface. And that is very, very convenient and suitable for automobile body. But I do not think BIS has still woken up. So at some point, through some channel, we need to emphasize the necessity of introducing updated standards on the different galvanized products available in the market in India and being manufactured in India. That will take us a leap forward in the matter of international market of galvanizing. That's from my side.
Thank you. Thank you, Dr. Shantanu. Thank you. Now to Mr. Sandeep.
I think lead is definitely here to stay because of the huge demand, and it's a very stable, proven technology in the lead acid battery. And considering the advantages we have with regards to a large lead acid battery manufacturing setup, a very good collection network for collecting old used batteries, and a very robust recycling network in place. So the whole ecosystem is well connected. So that ensures that lead will continue to stay and will continue to play a big role. The only thing is if the government can put up some more incentives that I mentioned earlier, that I think will further strengthen the ecosystem. And finally, lithium, we keep talking about lithium, but there frankly isn't enough lithium to satisfy the needs of probably India alone, let alone the world on a long-term basis. So yeah, that's all I'm.
Thank you. Thank you. Thank you, Mr. Sandeep. Sir, Pugazhenthy sir, you want to make any last comment? You already made.
Yeah, one excellent point our friend Shantanu made during his concluding remark. BIS is a sleeping giant. I've been a member, I've been chairman of that committee. See, if BIS becomes an autonomous, independent body like ASTM, TIN,
Yes.
JS, then they
Yes.
will be more effective.
Yes.
Now, BIS today is tagged on with Ministry of Consumer Affairs. And they're reporting to the minister. When IAS retired guy comes there as DG for 3 years, paperwork, circulation and all that. So this is what is the malady with BIS. And all of them, they call themselves scientist G, scientist D, B, A, all, PhD, IITs and all that. I see the top there. So it has to be a private body. They will make money, they will make good work, they will look at the international standard, they will look at what is happening in the industry. There will be live wire activity in only then. The second point I wanted to say is what Sandeep said, lead is here to stay. See, as long as in this country, construction, infrastructure and automobile industry keeps on going up with massive investment, renewable energy storage, national highways, Vande Bharat Express, railway electrification, 5G, 6G, so many things are happening. So as long as these three things keep going, construction, infrastructure, automobile, zinc and lead will have a very pleasant travel going up and up all the coming years. That's all I wanted to mention. Yeah.
Yeah, of course, sir. I do agree with you. In fact, I always say that infrastructure development of our country revolves around steel and metals because it is the economic growth because of the infrastructure development. And steel and metal are at the center of this infrastructure development. So we cannot imagine growth of our country, economic growth of our country without steel and metals. So lead and zinc also travel in the same bogie. So
Also, India is the third largest producer of automobiles in the world.
yeah,
Ask SIAM, ask SIAM. Third
yes,
largest, it is going up and up.
yes. So
And I think you can summarize by saying what Muthuraman said, our Muthuraman said in 2006 or 2007. As a passing remark, he said, do you know steel is still interesting? Steel is still interesting.
Why? Steel is interesting.
yeah,
It will always be
I can
interesting.
remember two very distinct advertisements, one from Tata Steel and one from SAIL. Tata Steel says we also make steel. That was very famous advertisement, and that also says a lot of things. And SAIL, that SAIL advertisement, there is little bit of SAIL in everybody's life.
Exactly.
So there is little bit of zinc and lead in everybody's life. So
Danesh, I have a request, personal request to you. I have not seen this magazine, your Steel World and Metal World.
I will send you. I will send you, sir.
I would
Put him
like
on.
to have a hard copy sent to my address. I'll send you my
I will
address.
send you. I will.
Also to Sandeep, also Metalworld.
Definitely, I will.
I'm
I will
getting
add
both.
in our
I'm
list
getting
so
both.
that-
I'm getting both. Yeah.
Yeah. So anyway, thanks very much, sir. Mr.
Thank
Pugazhenthy, Dr. Shantanu, Dada,
you.
Mr. Sandeep, thanks very much for sparing your time. I would again say that you are the experts in the field and you have your time. Very,
Wonderful brainstorming today afternoon.
Yes.
So we are
Friday the 13th.
and very informative and knowledge sharing
You
debate.
should give you should give us a cup of tea now.
Yes.
I will
Virtual.
send it through WhatsApp.
Virtual tea.
Wow, virtually. Thank you, Sandeep. Thank you,
Thank you very
Sandeep.
much.
Thank you,
Thank you.
Shantanu.
Thank
Thank
you,
you.
Shantanu.
Thanks.
Thank you.
Thank you, Shantanu. Thank you, Sandeep. And thank you, Chandekar.